The art of fingerprinting air pollution lies within the neutron, the non-charged part of an atom. Neutrons have different weights, called isotopes, and these very slight differences in weight can forensically tell us where air pollution is coming from. Using isotopes to trace chemicals isn't new. Anthropologists use it to determine where someone lived during their lives, and we can even use isotopes to trace manufactured goods back to their country of origin, like illegal drugs or even bottled water. But using isotopes to trace air pollution, well, that's about 20 years old. For science, this field is an infant, and there's still a lot left to understand. One of the misconceptions about air pollution is that it stays near where it's produced. And sometimes that is true, like in Salt Lake City, Utah. This city is surrounded by mountain regions and has a lot of factories. So a lot of the air pollution that is made here stays here, trapped by the topography, leaving the city in almost perpetual smog. But air pollution doesn't always stay near the source. This is a weather pattern moving along the jet stream, and we can use this to kind of visualize how air pollution might move from one place to another. In 2017, New England sued the Midwest because air pollution was proven to have traveled from the Midwest all the way to New England and deposited here. But because air pollution is so mobile, it's harder to trace. And what we absolutely do not want to do is accuse someone of producing pollution that didn't. Think of it like criminal forensics. We need to make sure that the fingerprint accurately matches the suspect, or we end up accusing the wrong person and punishing them unjustly. This is what I do. I make sure that the fingerprint accurately matches the suspect. So when the Midwest emits all of this air pollution and it goes through chemical change and transport and deposits here in Providence, in our ground and in our water, we can figure out where that pollution came from, and we can figure out which pollutant is causing the most harm. In the Hastings lab, we focus mostly on nitrogen pollution. Nitrogen is a food for plants, which sounds good on paper, but we need to remember that not all plants benefit us. This image is of a severe algae bloom fueled by nitrogen pollution. And when algae blooms like this, it consumes so much oxygen in the water that there isn't a whole lot left for other aquatic species, and massive amounts of fish die. Algae blooms are bad for water ecosystems. They're bad for water quality, the water you and I drink, and they're even bad for the economy, affecting tourist trades and fishing incomes. I figure out how best to capture air pollution. I figure out what will and will not affect the fingerprint. The environment is unpredictable. It's dirty. There are so many variables that can affect how we lift that fingerprint. Changes in humidity, in temperature, even in how much or how little pollution is present will affect how well we lift that fingerprint. Most of my days look like this. I spend every day in the lab changing one variable at a time to figure out which ones will or will not affect how we collect air pollution. So when other scientists are out chasing wildfires and climbing 20 feet in the air over open water to collect these air pollution samples, they know that they aren't risking their health and their safety for nothing, because these samples are good. They will be good samples. And that is why my research matters.